This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic. This is part 11 of graphing cosine functions, and we're going to graph y equals -3 cosine of pi x. So we see a couple things here. We see there's a coefficient of -3 in front of the cosine, so that tells us the amplitude, right? So we know the amplitude is going to be the absolute value of -3, which means it's going to be 3. Now what about the period? The period is going to be affected by this pi in front of the x. Okay, now you're used to maybe seeing a 2 or a 3, but it could be anything, and pi is the number 2. So when I say 2, I mean a number also. So how would I find the period? We take the regular period for cosine, which is 2 pi, and we divide by that coefficient. So in this case, notice that b is equal to pi, and to get the period, you take the regular period for cosine, which is 2 pi, and divide by b. So you're dividing by pi. Notice the pi's cancel. So you have a period of 2. So the period is 2. Notice it's not 2 pi. It's just the number 2. Okay. Now remember, we need to figure out what a fourth of the period is for getting our key coordinates, so x coordinates. So a fourth of 2, right, a fourth of the period, is just 1/2. So in other words, if you had your first x coordinate, you would add a half to be halfway there, then you'd add half again, the number half again, you have gone 2 units. So the period will be 2 pi. Now where's our starting point? That's basically decided on by the phase shift, and there is no phase shift because we don't have any number added or subtracted, right? And we also do not have a vertical shift because we don't have plus something at the end. All right, so there's no vertical shift, there's no phase shift. What's the domain? It's always the same, -infinity to infinity for the cosine and the sine. And the range, we'll figure that out in a minute. What do you think it's going to be? Well, if the amplitude's 3, then and there's no vertical shift, it's going to be going down 3, right? And then back up 3 to the top. So the range is going to be from the -3 to +3. And when you graph it, you should be able to see it if you can't figure it out by thinking about that amplitude right there. All right, so what are our key coordinates going to be? Our key x coordinates? Well, normally, remember, it goes to 0 to 2 pi, but this time we're going to go from 0 to 2. Since there's no phase shift, so this is going to be easier than you might think. We want to do -3 cosine of pi x, right? So we'll start at 0 because there's no phase shift, just like on all of the ones where we start with a cosine. Remember, the usual values here are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Whoops, sorry. It's getting away from me here. And 2 pi. And remember how it goes. 1, 0, -1, 0, 1. Okay, but my x coordinates here are going to be different because to get the first x coordinate, we start with a 0, that's fine, but then we're going to add a fourth of the period. That's this 1/2. So what's 0 plus a half? It's just a half. Add a half to that, you're at 1. Now, if you want, you could write 2 halves, that's fine. And then you're at 1.5. If you add half again, and then you're at 2. And that gives us this full period from 0 to 2. Now, this -3, how does that affect it? Remember, you're going to have to do -3 times these usual y coordinates over here, which are 1, 0, -1, 0, and 1. So my y coordinates are -3, 0, 3, 0, -3, and now hopefully you can see the range does go between -3 and 3, which I had up here. Now, of course, it's not a bad idea to check. For instance, if you did put in one of these numbers for the x into this equation, make sure you really do get that y value. Let's just do a quick check because, sometimes you make some mistake. You go on autopilot and you're not really thinking. So what if you put in 1/2 for x into this equation? So let's just check it. If you put in 1/2 for x, you'd have the cosine of pi times 1/2, which is the cosine of pi over 2. And what is the cosine of pi over 2? Remember, that's the cosine of 90 degrees. The x-coordinate is what at 90 degrees? It's 0. So this is just -3 times 0, which is 0, which is what we had right here when I put in 1/2, right? See this -3 times 0? So this is a shortcut, right? Here's the long way of doing it. You actually plug in each of those numbers one at a time and figure it out. So it looks like we're on the right track, so we're ready to graph. So just go down a little bit and graph it. All right, so here's where you got to be careful here. Notice there's no pi anywhere for my x-coordinates or my y-coordinates. So my x-coordinates are going from 0 to 2. So I'm just going to label my x and y-axis like I normally do. My y-coordinates go from 0 to 3. I'm going to do the easy way. I'll just call that 3 and that -3. And my x-coordinates are going to go, how about calling that 1 and calling that 2. If you want, we can make more. But you want to make it easy to see where 1/2 is. So let's graph it. We've got 0, -3. So here's 0, -3. There's our first key coordinate. We have 1/2, 0, 1, 3, 1.5, 0, and 2, -3. And there we have 1 cycle. Now you can keep repeating this. Remember, the cycle does keep going if you want to see 2 cycles. But do show what's going on over here. It's going up at this point, right? It starts going back up again. So there we have it. You've got our graph. And up here, remember, I already wrote what are the amplitude, the domain, the range, the period are right here. So I'm going to just go down, put them under here as well. And voila, our graph. And domain, range, period, and amplitude. There was no phase shift and there was no vertical shift, so I don't need to list those. This is your math gal, Julie Harland. Please visit my website at yourmathgal.com, where all of my videos are organized by topic.